I'm Rebecca Hasgard and I'm an expert in speaker recognition. First, I'm going to talk a little about biometrics in general and explain a little bit before I move on to speaker recognition, which is my area. Biometrics is automated methods of identifying or verifying the identity of a person based on physiological or behavioral characteristics. And some biometrics are fingerprints, signature recognition, facial recognition, iris, and speaker recognition, which I'm going to talk about more specifically.
A typical biometric system is comprised by 5 integrated components. First, you have the sensor that collects data and converts information to digital format. Then you have the signal processing algorithms, which perform quality control activities and develop the biometric template. The data storage is where all information is kept and that the new biometric templates will be compared to. Then we have matching algorithms, which compares the new template to one or more templates kept in the data storage. And last but not least, we have the decision process that uses the result from the matching component to make a system-level decision.
Automated biometric systems has only been available for a few decades, that because of computer technology. Now, the new techniques are based on ideas conceived hundreds of years ago. And here is the timeline of the biometrics, and we'll get a close-up on this. Here you can see a timeline of biometrics, and the different color represent the different biometrics history. Now, one of the oldest and most basic examples of a characteristic that is used for recognition by humans is the face. Humans has always used faces to identify known or unknown individuals. Now, the timeline starts with a cave that is estimated to be 31,000 years old, which had handprints surrounding paintings on the wall. In 1870, we got the Bertillon system, which was measuring various body dimensions, and this field was called anthropometrics. In the 1800s, Galton developed a classification system for fingerprints, and later also Hendry developed a fingerprints classification system. Now in 1903, New York State prisons started to use fingerprints. In 1960, first model of acoustic speech production is created, and it was a Swedish professor that published a model describing physiological components of acoustic speech production. Now, it was based on analysis and x-rays of individuals making specified phonic sounds. And later in 1970, behavioral components of speech are first modeled. In 1976, first prototype system for speaker recognition is developed, and in 1980s, NIST speech group is established. Speaker recognition is automated methods of identifying or confirming the identity of an individual based on his voice. Now, there's a difference between speaker recognition, which is a biometric, and speech recognition, who isn't a biometric. The speaker recognition is to recognize who is speaking, while speech recognition is to recognize what is being said. It's about the words and how they're articulated, which is not a biometric. Speaker recognition is considered both a physiological and a behavioral biometric factor. The physiological components is the structure and the shape of an individual vocal tract, while the behavioral components is the movement of the jaw and the tongue, and is the motion of the mouth and pronunciations. In speaker recognition, we use the pitch, the tone, and the rhythm of speech. And it's the underlying premise that each and every person differs in these factors enough to have a uniquely distinguished voice. Factors that contribute this is the articulators, which is the size and shape of the mouth, the throat, the nose, and the teeth. And also is the shape and tension in the vocal cords. Speech is produced by air passing through lungs and the throat, and then the vocal cords, and at the end the articulators. Now, different positions of the articulators create different sounds, and this creates a vocal pattern that we analyze in speaker recognition.
A visual representation of the voice can be shown in a spectrogram, and here you can see an example. It displays the time, the frequency of vibration of the vocal cords, which is the pitch, and amplitude, which is the volume. Now notice, the pitch is usually higher for females than males. The accuracy of voice authentication is affected by several factors. First of all, the difference in telephones can be really problematic. Background noise, illness, and vocal changes from age can also all affect accuracy. This spectrogram looks very much like the model we use for this case to analyze the vocal patterns of the female's voice. This is a map with comparison of biometrics where speaker recognition is compared with the biometrics fingerprint, face, and iris. And this will help us get a better understanding of speaker recognition. When it comes to the universality of speaker recognition, people who are mute or having problems with a voice due to severe illness, this biometric solution is not usable. Because of the combination of physiological and behavioral factors, the voice is a unique feature of an individual. In fact, it has more unique features than a fingerprint. A common issue for speaker recognition, fingerprint, and face is that it changes over time. When you get older, the voice will change. And speaker recognition is also influenced by factors like sickness, stress, and tiredness. When it comes to collectability, voice recordings are very easy to obtain, and compared to the other biometrics, it's also very cheap because in speaker recognition there's no special hardware required. And really, the real advantage with speaker recognition is that it can be done over telephone lines, or you can use a computer microphone. The important thing to remember then is that telephones has different sound quality, which can create issues when it comes to analysis. The storage size of voice print is also small, and it can be stored in almost everything, like smart cards and phones, almost everything. Speaker recognition is easily accepted by users, and the reason for that is that speaking is a natural process, so no unusual actions are required, which make it more acceptable for the users compared to iris, where they have a concern about eye safety. The major issue when it comes to speaker recognition is spoofing using voice recordings, and spoofing is tricking computer systems and is usually to hide or fake someone's identity. Errors like misreadings and mispronunciations can create issues for the performance of speaker recognitions. And speaker recognition is not the most secure of biometric technologies, and therefore it is not appropriate to use independently for authorization to systems that requires high security. And therefore it is also impossible to only use that as evidence in a case. An important thing to know about speaker recognition is that it is the only biometric that allows users to authenticate remotely. And speaker recognition is different from some other biometric methods in that speech samples are captured dynamically or over a period of time, such as a few seconds. An analysis occurs on a model in which changes over time are monitored, which is similar to other behavioral biometrics such as dynamic signature and keystroke recognition.
Speaker recognition is quick to enroll in a voice authenticate system. The user is asked to speak a set of words or phrases, or to speak of a certain length of time. Now from that sample, a digital representation of the voice, also called a voice print, is created. A good voice print lasts from 2 to 8 seconds of speech. Authenticating a user is accomplished by comparing the voice print that was created at enrollment to a sample given by the same person earlier. And authentication is very fast, it's completed in less than a second. There are two types of speaker recognition, and the first one is called text dependent. This is where the individual has to say a fixed phrase like a password, which is the same for enrollment and for verification. Or the individual is prompted by repeating a randomly generated phrase. An example of this is if the system asks you to please repeat the numbers 16, 23, 42. Then we have text independent, which is recognition of whatever the subject might say. Now, text dependent shows a better performance for subjects that cooperate. However, text independent is more flexible. Why? Because it can be used for non-cooperating individuals, which is very important, especially in cases. There is no question that voice biometrics will continue to grow in popularity in the future because of the ease of use, user acceptance, and the remote authentication capabilities. And it has already started to become a part of our daily life, especially for those working in security. Maybe in some years, voice biometric will replace physical keys, cards, and passwords on computers. In fact, computer security will probably be more voice related. Instead, I'm coming to a bank to take fingerprints. Maybe you can do transactions over phone with voice biometrics. Maybe you can use voice biometrics to pay instead of Visa. That's some of the possibilities we have in the future of voice biometric. On November 25th, Hannah Curry was called in for a hearing by the police about her husband, Billy Curry, that was murdered in the living room 3 days earlier. Now, Hannah Curry says she's innocent, but the police still has her as a suspect in the case. Hannah Curry was the first person that found her husband dead on the floor, with a knife beside him and blood everywhere. Hannah Curry made a phone call to the police the night that her husband was murdered. Now, with voice biometrics, we are now going to compare the two different vocal patterns, one from the phone call the night that her husband died, and one vocal pattern from the hearing with the police. This will help the police getting one step closer to solve this case. We will now listen to Hannah Curry's first phone conversation with the police the night that her husband was murdered.
Oh my God! He's dead, he's on the floor and I don't know what to do, there's a knife and I can't, oh my God. He's dead! There's a knife and there's blood.
Here is the vocal pattern of Hannah Curry's first conversation over phone with the police. The next evidence we will listen to is Hannah Curry's conversation with the police at the hearing.
I walked in the room and there he was. He was on the floor and there was blood everywhere. I didn't know where it was coming from, but it was everywhere. And then there was the knife. And I didn't know what to do. So I walked to the phone and I called 911.
Now, when we saw the comparisons of the two vocal patterns, we could find several proofs that Hannah Curry was guilty of killing her husband. The first proof is the pitch of the tone in the different vocal patterns. When a person has experienced a situation like that. And when they are talking about it and reliving it, the pitch should go as high as it did when they first experienced it. Now, the voice pitch of Hannah Curry's voice and the two vocal patterns are completely different. Another proof was the rhythm of speech in the two vocal patterns. When reliving a situation like that, the rhythm of speech should increase in speed. But Hannah Curry's rhythm when she talked to the police did not increase, and this could make the police very suspicious. The tone in Hannah Curry's voice is also too different in the two vocal patterns. In the first one, she's crying and scared and stressed out, which she should be reliving some of those emotions while she's telling the story to the police. However, Hannah Curry's voice doesn't seem sad at all. The tone in her voice does not go up to the level as the first phone call, which is also very suspicious. Based on only voice biometrics, we can conclude that Hannah Curry was guilty in murder Billy Curry.